started, I'd like to introduce Eric Miller, who will be presenting Get More from Your V4 with Carrier Grade NAT and Proxy ARP. Eric is a network architect at GiGstreem and is coming to us today from Orlando, Florida. This is Eric's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome, Eric.
Good afternoon. I did not plan on having a knee scooter when I originally signed up to speak, so I appreciate everybody helping me out with that. Let's give this thing a shot. So GiGstream, we are a mostly residential service provider. We deal primarily with the MDU space, corporate apartment housing, and commercial buildings in downtown areas. We're somewhere between an integrator operator where we show up to a property and there's equipment waiting for us to install. We do the underground, bring it all online, and then share in the operational management to deliver a retail internet product. The size of our network, we're about 12,000 customers growing, and we have a fractured IP space, but collectively it's about an 18, and we're already deploying V6 across our nationwide footprint. We offer two different types of service where on one, what we call our instant on platform is your typical provider platform where you're asking the customer to bring their own router, or we're providing like a managed Calyx router. And then our more premier product that we sell mostly is what we call ubiquitous Wi-Fi. You can imagine it like enterprise Wi-Fi deployment at an apartment complex. And so we're actually selling Wi-Fi, not really internet. And then we also provide traditional commercial services in an MDU, both at the enterprise level and at like Soho. Of course, know your audience. We're trying to make this talk about for people that want to increase the efficiency of V4 space that they currently operate, as well as maybe you're curious about how we've been able to do this within our organization. I was a junior engineer at some time ago. I'm sure that everybody here, at least at some point, has been there as well, where we try to save a 24 by having some obscenely large layer 2 segment. You get all sorts of things of people stepping on each other's IPs and spanning tree loops and the whatnot. Maybe you've tried using community, private, and isolated VLANs and run into a bunch of fun issues with that. And you probably even have a V6 assignment from Aaron that you've been sitting on for a long time and not actually being used. So we ask ourselves, well, how do we get more from what we already have? And then we ask, well, where are we going to get it if we don't already have it? You're not going to get it from Aaron. It's going to take 2-3 months, and your business is going to go broke while you're waiting on that wait list. You can go rent it from the default route providers. There's a lot of legacy space still out there, and they're willing to sell it to you. I think just this morning I got a marketing email down in the signature line that said, P.S. we have lots of space available. And I think there's somebody in a trench coat out the back door there that's willing to sell it to you if you have a large enough pocketbook. And pretty much after that, you're kind of on your own. We'll just acquire a company that has the space and then rob the space, as part of the acquisition. But to each their own. But then where are you going to get V6? Well, it's everywhere. It doesn't cost hardly anything. They'll practically give it away if you just sign your signature for it. So we definitely need to do more V6. So getting into like what do we do with the V4 customers? Obviously they got to have a V4 address if they're still going to use the internet today. I had a really healthy debate last night about the virtues of CGNAT versus NAT 6.4. Does anybody raise their hands if they're using NAT 6.4 actively in a subscriber network? Not really seeing any hands raised. That's kind of what I thought. Anybody using CGNAT already? A couple of hands, yeah. One mistake that a lot of smaller carriers, where I come from, a small carrier, somebody under 10,000 subscribers, it's a lot of the WISP community and community carriers. They end up giving their customers 1918 space, and there's trouble with that, right? You get IP overlaps between somebody's BYOD has the same IP address that you're trying to give them on the WAN side. They connect to a VPN at work, and their IP space that they plug directly into the internet for their device might overlap with the IP space at their enterprise, and then you're fielding that concern. So we go into a couple of things here where we talk about where it's comfortable. It's it's very plentiful, but it's not prestigious. It's not the right way to do this. And one of my favorite topics here is BCP38 ACLs. We got to be a good neighbor and protect the internet from our customers, because a lot of times our customers run bad stuff on their computers and they get owned with DDoS. So what we instead want to do is utilize the RFC 6598 space, 164/10. There's a lot of it. You practically can consider it as if it was a public IP address when you're planning your network. Most carriers out there can fit their entire footprint inside of /10s. There's only a few carriers that are larger, really, that much larger than that. And it certainly is. You end up with not having a bunch of the issues when it comes to NAT 444 and overlapping IP addresses with their inside IPs and their outside IPs. And then also specifically in the RFC, Section 5 gives hints to application designers on how to utilize this space when they're designing their firewall settings, whether or not they're expecting to be able to reach a port open on the far end. And then this last point, I was reading my slides preparing for this, and I'm like, why did I even put that in there? But what I think I was trying to get a association here is that we can make a /24 go a lot further and with a lot better, slicing the pie up when we design our network with CGNAT space as if it was unique across the board. At GiGstream, we use the CGNAT space as if it was public IPs, and so then when we get to dividing up our actual public IP addresses, we're able to apportion the IP space so that it fits comfortably across the pods of our networks, which we affectionately call a latency zone. And in fact, if you use Calyx managed routers, we use the Calyx U4 mesh and the gigacenters, and that their Calyx cloud service will use TR069 to tell the router to open up its WAN interface when you want to log into it, when your customer care wants to log into it. So you can't do that if you have NAT between your customer care PC and some RFC 1918 space. Your network has to be fully routable back and forth through the NAT system. So when we give 164 space to our Calyx routers and we allow that space to route through our network from the customer care team, then they're actually able to remotely log into these routers when the Calyx backdoor gets opened up. Essential is if you're doing CGNAT, you've got to do V6 at the same time. There's a couple of things that we've noticed that we usually rely on, or they come out of CDNs, and I'll get to that in a minute. So in the same apologize, after surgery, my vocab hasn't come back. All right, I'll just read it. Less comfortable. There's a lot of the space out there for V6, but there is a learning curve, and you have to issue it in a controlled manner. It's so plentiful that you can just throw it out there, but you still need to plan your deployment. It's definitely prestigious, especially if you're a small provider offering V6. We still don't see that among the smaller ASNs out there. GiGstream, we do run full dual stack, and we do take pride in that. And last night I was encouraged to put together another presentation for the fall where we talk about how many of our dual stack customers in our ubiquitous Wi-Fi environment, where we do get to see statistics to the device level as opposed to just the customer level. We would like to explore what the ratios of traffic are, at the iPhone versus the PlayStation level. The biggest trouble that we have with the CGNATs is with CDNs. Most of those CDNs, through their protection policies that they've put into place, mislabel our V4 space as VPNs, because when you're looking at it from their side and they see that there's 30 unrelated people accessing their services from the same IP address, then it looks like a VPN. So I totally understand the issue there, but giving them the benefit of the doubt, the CDNs are actually the places where we see the most V6 adoption. I did look up one property that we have where we did recently do a V6 transition, where we saw immediately within 24 hours, 50% of the packet count became V6 and 70% of the bandwidth became V6 overnight. That was a site where we have about 30% with our Calix managed routers, another 30% or so with BYOD, older Linksys routers, et cetera. And then the remaining 30% are using our structured access point network, even though it doesn't really mean our ubiquitous Wi-Fi network. So we definitely would encourage everyone to do V6 along with their CGNAT deployment. So the different steps to CGNAT will require us to have a couple of requirements before we get down that road. Obviously, you can't start from zero. You've got to have some V4 space that you're able to squeeze something out of, but it doesn't have to be very much, as we'll go into. You got to have a layer 3 gateway that can do NAT, and that layer 3 gateway has to be able to cover a small geographical area. One of the other things, like with MaxMind and the other geolocation tools that are out there, what we found is that if your IP address that you're using as your NAT hide covers a large geographic area, you're going to have a bad time. So in our world, where we do commercial buildings and MDUs and not fiber to the home, entire districts or zip codes, we find that we naturally get the benefit of this, but we didn't realize that in the beginning. It wasn't until we tried to do it outside in the wild that we realized how important it was to keep that geographical area small. And it's almost to the point where if you open up Edge or Chrome and you go to guest browsing and you say, "Where am I?" You don't want to be 3 zip codes over. You want it to be in the neighborhood where you actually are, because the geolocation has settled in on that. And you got to have an IPAM. You got to have some way to keep track of these IP addresses, because they get large and very quickly. And you may even have a collection of V6 addresses that you're just sitting on. So step 1, going through your IPAM. Step 2, you got to plan the equipment you're using. 3, VLAN configs. This is talking about the southbound side of your gateway. 4, templated customer interfaces. 5, we'll go into a little bit of what NAT means for all of this. And of course, my favorite topic, BCP 38, protect the internet from your customers. So in our IPAM, of course, it's all about knowing how to slice your pie up. Everyone's is different, so take your time, and then when you're done taking your time, take some more time. You got to get it right. It's very detrimental to the future of your company if you misallocate your IP space. We acquired a company in New York City 5 years ago, and we have, I think, 5 or 6 /24s with 2 or 3 customers in them apiece, each using a 29. So we're actively working with our sales team, trying to convince these customers that they should change their IP addresses so that we can take those 24s and move them into areas of our network where we're currently renting IP space from our default route providers. And you got to have a good tool. I was so overjoyed coming here to Nanog and hearing people talk about NetBox. It's one of my favorite tools. It may not be the best tool out there. I'm sure everybody has an opinion on what the best tool is, But if you're not using something like that and you're still using Excel because it's cheap, it's time to upgrade into a tool that is well community supported now. NetBox. It's an open source project. I believe it was commissioned by DigitalOcean, or it started to be supported by DigitalOcean. So it's very data center centric in its originality, but it translates well into the service provider side. So going through like a /24, when we move into a new market, we're standing up a new data center, and we had to sign the lease for a /24 from a default route provider because that's all we had. These are some of the ways that we've sliced it up. I'm a little bit old school in OSPF and still like to have different areas for different types of networks to keep LSA problems down. As routers are getting better, we can have larger area zeros, but like I said, I'm a little old school. So we would divide up, /27s, 28s, 29s, 30s for loopbacks as you go around a ring. We actually use CGNAT addresses in our router-to-router /30s. We literally treat them as if they were public IPs. And then as we get down to the end of our infrastructure, where we're done assigning loopback addresses, then we have this, what's left of the IPAM that we call our block of blocks. And out of this block of blocks, we're going to grab like a /30 and say that if a customer wants a public IP address, we'll grab a /30 and send it over to that router with BGP or OSPF. And the /30's got 4 addresses in there. And we're going to give out all 4 to customers. And this is where you get into a little bit of the statistics game. If you pull /32s out of here and route those around, you're just going to have a lot of /32s around. If you assign /25s to an entire apartment complex, then you're just going to have a lot of space that goes somewhere that's never going to get utilized. We're finding that when we are running a CGNAT infrastructure, out of every 100 residents, maybe one of them, maybe 2 of them will pin us down and get a static IP out of it. So we're finding that if you give them V6, really the only reason why we're getting V4 requests for public space anymore are gamers that want to host games out of their house and they're having trouble doing that under CGNAT, or they're tinkerers and they want to run a Raspberry Pi with their web server off of it at their house, and maybe a couple other use cases. But we're not finding that people need public V4 space anymore. This was a sample 22 of a market that we acquired. They had a 22 in there and it was very fractured. So our, quote, block of blocks get pulled out into 26s and 25s kind of scattered around in here. Again, we were able to reorganize the network into to different OSPF areas with the different network technologies that are there. And then as we go through, we're still pulling out these blocks of blocks. One thing that I learned as a perfectionist, as a diehard perfectionist, after working at GiGstream for 5 years, I realized I'm not going to be able to make it perfect. And so I've had to learn that sometimes it's okay that something's not going to be pretty as long as we can make it functional. So when you're planning your equipment with CGNAT, we found that there's kind of 2 ways to build this. You have a centralized deployment, or you have a distributed deployment. We've done it both ways, but it's an individual company decision. Again, when you're small, you're probably going to more think about the distributed model because the networking hardware at the edge can be cheaper to do this in. But if you're a large enterprise, you may benefit from having all of that really centrally together, where the tool sets are more conducive to big data. But what you have to consider is the load that on CPU and memory that CGNAT's going to place in there. If you're already doing it, and you're just going to go into a better design of it, then your workload's probably not going to change. But if you're currently issuing V4 space to your customers and you're not tracking their connections because they're public IPs, Then when you start tracking those connections with a NAT table, it's going to put a pretty heavy load on that equipment. What we found when we first got started was using a dedicated BNG in the data center to do all of the V4 it was very appealing to us, because we're like, one double redundant pizza box set up and we're good. And then we ended up having some strange issues there where anytime we wanted to do network maintenance, we had to take the entire market down, where we could strategy plan out any upgrades and only affect a couple hundred customers at a time by having a redundant or a distributed model. And then as we kind of upgraded the edges of our network, realized that we could put in a single router that did the VLANs, the DHCP, the NAT, everything at the edge, and now everything is kind of self-contained, and we have a nice play there. So we currently use a distributed platform. But the third item here is syslog. We have clear requirements. The law is fairly old. I should say that I'm not a lawyer, so don't take any of this as legal advice. But under our interpretations of that, we feel that it's inadequately descriptive about what our requirements are for data logging. We know it's pretty straightforward from the financial and customer record side. You got to know who your customers are so that if you're subpoenaed, you can respond. But when it comes to actual network data about our customers, you kind of fit into two things of, either collecting data and ready to give it to the government, or trying to find a privacy balance there. Given no data, no syslogging of connections, when you receive a subpoena and you go back and you look at that IP address, because that's the only thing that you're able to match up with because ports you didn't record, you're going to be forced to give the US government or the state attorney or whoever 64 names that could be behind that IP address, and you're going to expose them to, potentially a dragnet. Only one person in that group of 64 is the target of the search, but you're going to respond back with 64 names. I'm a privacy advocate. I don't really like that idea. But at the same time, I also really like telling customers that I don't record what you do on the internet. And so it's a struggle. And so when I talk to attorneys, I'm kind of the security guy for the company as well. So when I talk to the district attorneys and I lay this out for them, it's a really, it's a strikes of a weird balance there. So in our organization, we've made determinations on a very limited amount of data that we will record for the benefit of responding to subpoenas, and everything else we just respond back with. It just doesn't make business sense for us to record any more than this. From NAT, you're going to end up with data. A lot of the ways of recording that data is through syslog. When you have a distributed infrastructure like ours, we make a lot of syslog data really fast, and it travels across the same network that our customers take. And so we have to have a robust, resilient way of collecting all of the syslog data and centralizing it somewhere. So if this is helpful, I can come back and go through the way that we do syslog collection. If you're in a data center BNG, you have one or two sources of that data, and it might be easier for you to collect it from that aspect as well. Going into how we design VLANs, we have the northbound side of the network, we have the southbound side of the network, meaning the layer 3 gateway. We configure every single one of our customers, residential or commercial, in exactly the same way. It's a templated configuration. We find that it really helps when training senior call center reps or junior engineers on how to learn how the stuff works. Of course, as the guys that set it up, we want to go home at night because we pay other people to work second and third shift. And if we continue to get escalations for seemingly simple issues, we're never going to have any time with our family. And so after we teach junior engineers how to understand the template and what type of variations there would be, they can actually take a customer that's working, compare it with a customer that's not working, and see what the differences are. You teach them to show ARPs and MAC address tables and that, and quickly they can figure out what's different between two customers that are set up the same way. Likewise, we're going to set up the interface the same way, but before I realize that this is a VLAN table. So when we do our southbound VLAN tables, we also like to have those ranges set up exactly the same way from site to site. Again, our infrastructure is a router at the top, and then an MDF switch, and then IDF switches, and wireless access points at the bottom. When we do an instant on setup, which is what IDF 1, 2 to 29 is, each port on the IDF switches goes to just to a different VLAN, and that allows us to move very quickly on getting a customer connected. So we could think of the IDF structure as almost like just a giant port extender. When we do wireless access points, it's kind of the same thing, except the IDF is not where the customer VLAN assignment happens. That happens at the wireless access point. And so we have another set of just port extenders there with the Wi-Fi network. The 2 to 255, because we're Wi-Fi, when we jump into managing the network on the property, sometimes they will have their own small business network in the leasing office, but we're going to do the Wi-Fi for them across the whole property. So we're just going to hand off like a VLAN, like a layer 2 setup over there. So when we go to configure the interfaces in the router, just a little pseudocode, we start by creating the VLAN. We throw a v4 address on there. Then we throw a v6 address on there. Really love the UE64 Slack. Tell it that, hey, we're going to send you some other managed configs so you can get your PD. And then, of course, my favorite at the end is BCP38ACL. A couple of examples here for how we would do it on a Juniper. We'd create our VLAN picking on 999. We throw a CGNAT block on there and a v6 address. Looks fairly similar to how you would configure a customer that has a /27 of public space. If you're a Cisco iOS guy, here's our XE config with the addition that we have IPNAT inside since you do interface config with NAT. And if you're a MikroTik guy, then we have a similar config here as well. Now, NAT concepts. So a couple of things with NAT. You'll hear some things thrown around like CGNAT is NAT 444, which is you've got your guy with his Linksys at his house and he's got 192.168 there, and that gets natted into 164 in the middle, and then over on the other side you get natted into a public space. So that gets thrown around in concurrency with CGNAT. But really what we're doing is just taking multiple inside customers and sending them out to the world behind a shared v4 address. As you get into larger sites, you might run out of source ports on a single IP address. There might be a platform limit on the amount of v4 customers you can put behind a shared IP. So you might need to put multiple IPs. For us, we found that the magic number in a v4 only world is 64. If you put more than 64 residents on a single IP, the likelihood of them all having a PlayStation and trying to hit the same PlayStation server is, getting more and more likely. And we found specifically that some of the gaming console servers out there will start rejecting connections after too many gaming consoles have connected to them from the same IP. Whatever that is, whatever the reasoning for that is, we're finding that that's more and more likely now than it was yesterday. So when you get to larger infrastructure, you just put more than one IP in a pool. Most of the software packages out there can do PAT with multiple IPs, and you get multiple ports out of that. Another problem that we're finding is with UPnP. Wonderful idea, very limited execution. We would like to see a change there. UPnP allows us to use our PlayStation or our Xbox and ask the router to open up a port forward for us so we can host a game. Great concept. If that router doesn't in turn send a UPnP message to my CGNAT server, great, you got a port forward from 164, which doesn't internet route, down to your 192.168, and you're stuck. So we've addressed this a couple of ways. But we're not seeing a likelihood of that changing. We're thinking that we're probably going to see more or less gaming servers and stuff going to v6 and just sidestepping it. Why continue to build out something that we should be working to get rid of? So with that, we do not do static destination routes for customers. Imagine if you did, and you put one in, a couple of them a week, so people call in and ask for it, and then a year later you have some customer churn, and a year later you go back and you look at that list, and there's a bunch of stuff in there, and so you've got a whole bunch of ports that can't be used as source ports against that same IP tuple, and you get all the stuff in there, and that customer's not even a customer anymore. So you get it gets messy real fast. So what we do is we say, oh, you want to do something where you want static inbound service on v4, then you need a static IP. We work with them to either give that to them at a monthly rental rate, or we ask them to upgrade to the next level of tier. And I think we have to use the microphones for questions. But we'll try to get that customer on a static IP. We don't even do it by DHCP because we have a crawler that we run through and look for statics that don't go to ARP so that we can pull those addresses back because we're very hawkish on preserving our IPs. Yes.
What's your workaround for the UPnP when your customer doing a gaming? Do you put them on static also?
We make them go for static. And we find that works. Like I said, we have to balance customer satisfaction with we have to have a network that's scalable and works. So there's a lot of emotion that plays into that that's hard to build a straight business rule around. What we do find with UPnP at our ubiquitous Wi-Fi sites, where a customer is actually getting on our network and it's NAT 4.4 rather than 4.4.4, is they connect their PlayStation to plug in the access point of the wall or connect it wirelessly. They're on the only NAT. So then when they do a UPnP against a CGNAT server, then the UPnP is responded to and they actually do get a temporary port forward. There's one way that you can do this. You could do a one-to-one NAT with that customer. Certain packages software packages will make that easier than others. We just decided to go 0 or 1. You're either using CGNAT and it's all dynamic, or you're going straight for static IP just like you were a business customer. And then as part of this, we're going to make use of 253 out of the 256 IPs in the /24 utilizing Proxy ARP. Again, BCP38. You got to have that on your interfaces to protect the internet from your customers. But that does raise an interesting consideration. If anyone hasn't looked it up by now, BCP38 is this idea that in order to protect the internet from distributed denial of service attacks, we need to make sure that our customers are not sending traffic through us that doesn't belong on the internet. So if your customer has some misconfigured route and they're going to try to reach some 192.168 address out on the internet, you need to drop that in your core. If you have a spoofed IP address, a source address that doesn't belong on your network, you need to drop that in your core. So by the time it gets up to our upstreams, now we're creating a bunch of work for all of the DDoS guys out there to deal with. But it's an interesting question. What do you do for hairpinning here? When a service wants to go peer-to-peer between two CGNAT customers, how do you handle that? This is a point that's a little bit unknown for us. We don't really know what the best way to do this is, so I'm happy to entertain some comments. If you have distributed NAT, which we do down at the network edge, it's very easy for us to either filter or NAT first. We could do one or the other. We could say if you're 164 and you're trying to reach 164, we could drop you. If you're 164 trying to reach 164, we could NAT you and make it a public IP. So we're really not sure what the best way to do is here, and it's open for discussion. Now efficiency. Now that we've covered how kind of some of the concepts of CGNAT, what if you're not made of v4? course, I'm not going to sell you any of my space. There's people out here that do. But we want to continue to do one VLAN per customer. Layer 2 isolation between customers is paramount to the success of keeping customers from messing with each other. But that typically means that you're doing something like a /30 or 29 or something, and you're using a lot of space. It's really frustrating if you go buy a /24, break it into /30s, and say you bought it for 10 or you're renting it for $10 an IP. It's actually costing you $40 per IP to get one customer online with a /30. So a couple of the things that were out there over the years is /31. It's been around for a while, and there's still equipment out there that doesn't support it. If you're still using PPPoE, there better be a good reason for it, because that's just old as well, and it requires a lot of pre-configuration of the devices that you're going to put on your network. And you tried to teach a junior engineer how effectively to use private VLANs. So what we do is we use Proxy ARP. Did you know that Proxy ARP does not, or ARP has no concept of a subnet mask? It's literally, I'm a MAC address and I'm looking for an IP. And the response is, I'm an IP and here's my MAC address. So without this concept of subnet mask, we gotta get that out of our heads. And we think about the information necessary to create that dual link of upstream and downstream. It's just the IP address and the MAC address. So when we go to configure an interface, we have to put some address on that interface. All the platforms that I've looked at and the ones I'm using here, they support either an IP unnumbered, where I'm going to go borrow an IP from another interface, or if it's more of a Linux type operating system, you can actually add the same IP address to multiple interfaces. And then we're going to use a /32 route, directed at the interface. So Proxy ARP is utilized to simulate the CPE's like uplink route. Proxy ARP is just an instruction to the router that says, hey, when you see ARP requests on this interface and you know how to reach that address through your routing table, you can respond and say, I am that address. And that works. No subnet mask required. So that happens in the uplink direction, Proxy ARP. And then in the downlink direction, we use the /32 route. Again, V4, V6 dual stack, they're separated. So none of the things we're doing here with Proxy ARP on V4 has to change what we're doing over here with V6. Doing this allows us to maximize the addresses that we get from a /24 or larger, as well as makes it easy for our less experienced, less knowledgeable people to get customers in line. We give every customer that has a static assignment from us a /24 mask and a gateway of .1. The assignable addresses now, and because we do that, is .2 through .254. You still don't get access to .255 or .0, but and .1 is being used by the router. So out of a 256 address block, we're able to put 253 customers on that in their own VLAN. Likewise, if you're working at something like a 22, you could do the same thing, but now you have to teach somebody how to do CIDR notation and understand what, for a given IP address, what the given default gateway would be if you're using a low order number. So when we do this in a Juniper config, I've removed the V6 config so that it's actually readable on the screen. Like I said, this Juniper works well with the unnumbered, so you have to have somewhere that you're putting that IP address that you're going to borrow on another interface. In this particular environment, usually you put that on a loopback. We were unwilling to mess with the loopback because this was an active router. And when you change addresses on loopbacks, they tend to go offline. So we just created a dummy VLAN that has no customers in it. And we put a /32 IP on there just so there's an IP address on the router as if it was a loopback. And then here, the magic command here is proxy ARP unrestricted. And then we call out that we're going to borrow the interface from 000.2. So that handles the uplink. And then the downlink is a qualified next hop /32 route. If you're a Cisco iOS guy, same type of thing here. In this case, we borrowed the IP from .4 VLAN. And in a Cisco world, it tend to work better for us. We get automatic summarization if we're using all of those addresses on the same router to just go ahead and put it as a /24 actual address on the unnumbered route. In other environments, larger environments where we might be taking that 24 and using it across multiple routers, you do want to play with your address assignments. You might create a black hole, a static black hole to summarize that /30 that we assigned to the site and route it off towards OSPF using a static to OSPF rule or something. In this particular case with the Cisco, we have an automatic summarization by using the /24 on the unnumbered. And if you're a MikroTik guy, the keyword here is ARP equals proxy ARP at the beginning. This MikroTik is more of a Linux operating system, and so you can put the same address on multiple VLANs or multiple interfaces. It shows up kind of funny in the routing table, but it works. And then a /32 destination as gateway. And I think that's it. Anyone questions? Comments? All right. Thank you.